Okay, well, welcome everybody. Looks like there are still a couple more seats. I see 1, 2, 3, 4, 5, and a couple in the middle on this side. But thanks so much for coming out and joining me today, where we'll be talking about correcting common mistakes when using async and await in .NET. My name is Brandon Minnick. I work as a developer advocate at Microsoft. And on the bottom of the slide today, you'll notice a couple links on the bottom right. This is a web page I put together just for us, just for today. This is where you can go to find all the things that we're going to discuss. So this is where you can find the slides. We're going to do some live coding demos. They're all open source. Got them all linked there. And if you want to keep going down the async and await rabbit hole, I've also linked a bunch of articles there that I used when I was learning more about async and await. So highly recommend checking those out because it's a pretty complex topic. So this is a subject that's near and dear to my heart. And I say that because everything we're going over today are actual mistakes that I've made in my apps. I am a mobile developer by trade. I like to make iOS and Android apps in C# using Xamarin. And I just remember getting back the weirdest stack traces, the weirdest crash reports from my users after publishing my first app. And it was things like exceptions that shouldn't have been happening, or my app was somehow getting into a weird state that when I compared the stack trace to the code, I'm looking at it and going, there's no way the app can ever get into that state because the code shouldn't allow it. Like, what is happening? And it really wasn't until I started kind of pulling back the covers on async and await to see how exactly the compiler handles async and await. How's it really working under the hood? Until I realized, like, wow, okay, I'm making a lot of mistakes. So thanks for joining me today. I wanted to share those with you. And let's kick it off just by talking about multi-threading. So a thread, think of it just as a chunk of code. So a thread basically just contains a chunk of code that's going to go through a CPU, and the CPU will execute whatever it tells it to do. So it could be a couple methods or functions, but we can have multiple threads with multiple chunks of code. And nowadays, with multi-core processors, if you have, say, a 4-core CPU, well, that means you can have 4 threads going through each core simultaneously. So multi-threading means you have code that can run simultaneously. It can also be that you have threads dependent on other threads, like maybe they're waiting for a long background task to finish. And with .NET, we are really fortunate because we have this thing called the thread pool. It hasn't always been there. If anybody was around back in like the .NET 1 days, you had to manage threads on your own. I mean, nowadays, we don't really have to worry about that. But yeah, back in the day, you had to create your own threads. You had to dispose your own threads. You had to keep track of all the different threads that are running. You had to figure out how many threads you could have. But yeah, nowadays, we are super fortunate in .NET that we have the managed thread pool. So the managed thread pool is basically where all these, we'll say basically all the background threads live, and it is orchestrated by this thing called the synchronization context. The synchronization context, think of it like a conductor up in front of an orchestra. So it's what cues this thread to start, and then when that thread's finished, it'll grab this thread and tell that to start, and just make sure everything's happening in the proper order. And with the thread pool, there is a limit on the number of threads on each device. Now, that limit is actually dependent on that device's virtual memory. Again, we don't really need to worry about too much about this, but it's kind of cool to know that the same chunk of code, let's say you wrote a block of code in C# that can run on an IoT device, well, that's going to have less threads available to it than that same chunk of code if we were to run it on, say, a server with 64 gigs of RAM. But again, if we start consuming all the threads, I mean, that's not great. We should probably fix that code. But if it does happen, thread pool just queues up those tasks, and whenever a thread is free, it handles it for us. So super fortunate to have this in .NET. And let's take a look at some actual code here to see what's actually going on. And so this is a pretty simple method. It's called read data from URL. We pass in a string. We new up a web client. We call download data task async, which we are awaiting. And then that returns a byte array. We return that byte array into a string, run a different method called load data. And if you're already thinking, why isn't this guy using HTTP client? You're totally right. This is kind of an old example, but I wanted to keep it simple. So yeah, in your code, make sure to use HTTP client, but just for the sake of simplicity, let's check this out. So with read data from URL, let's say thread 1 kicks off this method. So thread 1 comes into here, it news up web client, it initializes this byte array, and then when it gets to that await keyword, download data task async is run on a different thread. Now, for the sake of this example, I've called it thread 2, but it could be any thread. The synchronization context will just literally go look at the thread pool, say what thread is available, and if thread 5 or thread 17 or thread 32 is available, it'll just grab it and run the code on it. So let's say download data task async is running on thread 2 now, and because we called that await keyword, thread 1 is free to go back and do whatever. And this is huge. This is really important because if thread 1 was running this, that's bad. In any UI-based application, so web apps, mobile apps, desktop apps, thread 1 is what we call the UI thread. It is also known as the main thread. It's also what paints everything onto the screen. So anything that appears on the screen, that has to be done on thread 1. So main thread, UI thread, I'll probably use those terms interchangeably today. But if thread 1 was running download data task async, and let's say download data task async takes 10 seconds, well, that would have meant thread 1 would have been locked for 10 seconds. So what's that look like to our users? Well, they just see a frozen app. They try to scroll, they try to swipe, they try to click a button, nothing happens. And then what, right? They force quit the app, or they close the web page, they give us a 1-star review, they tweet out about how garbage our app is. But with async and await, we call that await keyword, and that frees up thread 1. So thread 1 is free to interact with the user. Meanwhile, thread 2 in the background is running download data task async. So when thread 2 is done, it goes back to the synchronization context and says, hey, I'm all done. Synchronization context says, great, which thread called you? And it goes, thread 1 called me. So what happens? Well, the synchronization context says, thread 1, you're back up. And thread 1 jumps back into this method and finishes it off. It continues to do the string conversion and run that method called load data. So not too bad. I think most of us in here probably have experienced that before. But what's really happening? To understand that, we need to go a little deeper. We need to go look at the compiled code. So here's that same method again, but here's what it looks like with the compiler-generated code. Now, the first thing I want to point out is that this is a class. It's a class that inherits from iAsync state machine. Now, I didn't write a class. I wrote an async task method. But what the compiler does, every time we use that async keyword, it converts our method into a class. But, I mean, no big deal. That does add about 100 bytes of overhead to our final app size, but it's 2019. What's 100 bytes? I mean, unless you're doing something on a small IoT board, 100 bytes per async method's probably not going to kill you. But it does. It turns it into a class. And all those local variables that we had in our class now become fields. And the variable names look a little different, but we can still see there's private string data, private byte array result, web client WC, and the URL, since it was a parameter, that stays public. And the only difference is you see some angle brackets and some underscores. This is just something that the compiler does for us because it needs to make sure that the variables it creates are unique. And it's never going to know what we named our variable, so it slaps some angle brackets on it, it slaps some numbers on it, just to make sure those variable names in the compiled code stay unique. Now, probably most importantly, is this move next method. If you've ever gotten a stack trace back from an async method, chances are you've seen move next. I know I have. And I had no idea what it meant. I kept seeing these stack traces come back, and I was like, move next? I never wrote a method called move next. Like, where's this code even coming from? Well, turns out that's part of this compiler-generated method. That's part of iAsync state machine. And here is what move next looks like. It's just a giant switch statement. And what we end up with, we have a case for every single time we call the await keyword, +1. So in this case, or in this instance, we have 2 cases in our switch statement because we called the await keyword once. If we use the await keyword 4 times, we would have 5 cases in the switch statement. But if we take a look at those cases, starting with case 0, this is just our code. And we can see here that's newing up the web client, kicking off download data task async, and then thread 1 returns. So this is how thread 1 is freed up. It literally exits this method. It's done. That's how it's going back to interact with the user and handle the scrolling and the tapping. But before it returns, it sets that value of PC to 1. And it does that because when thread 2 is done with download data task async, and the synchronization context comes back and says, hey, thread 1, you're back up, thread 1 jumps back in, picks up where it left off into case 1. And that's where it gets the results from download data task async. That's where it converts that byte array into a string, and then runs that method called load data. So pretty cool. This is something that I was impressed by when I first saw this, because think about what has happened. .NET's a framework that existed before multi-threading was really a thing. Existed before really like multi-core CPUs were even a thing. And the smart folks on the .NET team figured out how to give us just basically 2 keywords, async and await, and then they handle all this stuff behind the scenes, building out this state machine and making sure everything works properly. And all we have to do in our code is just slap async await on it, and it just works. Now, this is what got me. I did not see this coming. Move next is entirely wrapped in a try-catch block. Now, I didn't write a try-catch block in my code, but when the compiler generates this code and generates move next, by default it wraps everything into a try-catch block. So what's this mean? Well, it means that any exception that happens in my async task method, that exception's caught right here. Now, don't worry too much, because that exception gets rethrown as long as we use the await keyword. But if we don't use the await keyword, if we do what I like to call a fire and forget task, where maybe we say task.run, we put a block of code in there, we say, I don't care when it finishes, just go ahead and do your thing. Well, if we didn't await that task, and it threw an exception in that block of code, that exception's swallowed up and it's gone forever. So you might be thinking, well, that's a good thing, right? Like, exceptions suck. They crash your app. I'd rather have no exceptions. I'd rather wrap everything in a try-catch block. But over the years of coding, I've kind of come to learn is like, I want exceptions. Exceptions tell me when something's wrong. And when I know something's wrong, I can handle it gracefully. And this is really what was getting my app in a weird state. Was I was doing those fire and forget tasks. I was saying task.run, go, not awaiting it. That was throwing an exception. And now my code is in this state that it shouldn't be in, all because an exception got thrown and I never knew about it. So always make sure to await those async task methods. All right, quick review. The async keyword adds about 100 bytes, and that's just because every async method becomes a class. Now, 100 bytes, maybe that means something to you, maybe it doesn't, but it's good to know. It'll increase your app size by just a little bit. And then, like we just discussed, make sure to await every task, because non-awaited tasks hide exceptions. We want to make sure we throw those exceptions, or rather rethrow the exceptions, by using that await keyword. Okay, so now that we are async await experts, let's jump into some code and fix it up. So behind me, I have an app that I made to read Hacker News. If you've never heard of Hacker News, it's just a really cool website where a lot of tech news gets posted. And so since it's one of my favorites, I figured why not make a quick app? This is an app that works on iOS and Android made in C# using Xamarin. And it'll go out, it'll get the top stories from Hacker News, and I can click on any of these stories and give them a read, and that way now I don't have to launch my web browser to learn about, holy cow, Slack getting a $16 billion valuation. That's impressive. Good for them. But anyways, the code behind me, I will say don't worry about memorizing anything we're doing today. I say that because we're going to be working in this view model called bad async and await practices. But there's another view model called good async and await practices. So yes, the code's all open source. If you want to go back, share it with your friends, show your coworkers, you can just compare the bad and the good, because the good has everything done that we're about to do and fix in this bad async and await practices view model. And I'll make sure to give you a chance to grab that link again, and that's where you'll be able to find the code. OK, so the first to do right here, we have a method. This is a async task method that is actually a task of type bool it returns, and we're calling .wait. Now this is bad. I have a rule of thumb, and it goes, let's see, never, 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 never use .wait. Don't use it. It's a code smell. I wish it was never even put into the .NET framework. I actually reached out to the team at one point, and I was like, can we just deprecate this? And they're like, no, it's got to stay. Don't use it. Why is .wait bad? Well, .wait says, let's say thread 1 kicks off this method. So thread 1 gets to here. It hits set is refreshing .wait, and .wait says, hey, thread 1, you stay right here. You're locked. Don't go back and interact with the user. I'm hanging on to you. Meanwhile, it's grabbing a background thread to actually execute set is refreshing. So we have thread 1 locked, and that's bad, because now we can't update the screen, we can't interact with the user, but we're also having another thread run set is refreshing and setting that to true. And so not only is our app frozen, but we're using 2 threads when we only should be using 1. So easy fix. Whoops. There we go. So easy fix, get rid of .wait, and just use the await keyword. Now, I will say it's getting rare nowadays, but sometimes we still do need to use or write synchronous code. I mean, we're fortunate here where we are in an async method, but maybe that 1% of the time we still have to write synchronous code. So you're probably thinking to yourself, well, wait a minute, what do we do? Because you just said don't use .wait. Well, there's a better way to do this. Whoops, get result. There we go. And that's to use getAwait or getResult. Now, getAwait or getResult still isn't great. It does the same thing as .wait. It'll still lock the calling thread. It'll still run that method on a background thread. So we're using 2 threads when we only need 1. And also locking that thread if it's the UI thread. Well, now our app's frozen. But why getAwait or getResult is better is because .wait, well, we'll say if this method throws an exception, just like the await keyword, .wait will rethrow that exception, but it doesn't rethrow our exception. It rethrows what's called a aggregate exception. So system.aggregate exception, and that is an exception that holds exceptions. It's like exception inception, where our stack trace and our code is somewhere in that aggregate exception, but it's not on the top level. What getAwait or getResult does is actually it throws our exception with our code and our stack trace. So instead of getting an aggregate exception and having to dig through that to try and figure out where our code is, or if you have new developers on your team who have never seen an aggregate exception before, that'll just confuse the heck out of them. getAwait or getResult will rethrow your exception and your stack trace. So it's better than .wait, but again, we don't want to use 2 threads when we only need 1. We definitely don't want to lock up the UI thread, so we'll just use the await keyword. Done. And down here, same. We have another .wait, so this is an easy fix. We just slap the await keyword on there, and we're good to go. And yes, you can use the await keyword in the finally block, so kind of cool. That wasn't originally baked into async and await, but they gave it to us eventually. Next, refactor. So we have another method here. This one's called get top stories. This is what goes out, hits the Hacker News APIs, brings back, what's it do first? It brings back all the IDs, and then once you have the IDs, you can get the stories, and then we add them to our top story list, and we return that. So this one's not using .wait. It's using the await keyword, so that's pretty good. What can we do to make this better? Well, let's think back to that example we saw on the slide. So we'll say thread 1 kicks off this method. So thread 1 initializes top story list. Thread 1 initializes the variable top story IDs. We hit the await keyword, so thread 1's free, while a background thread runs get top story IDs. So let's say thread 5 is going to run get top story IDs. Well, when thread 5 is done, what's it do? It goes to the synchronization context. Synchronization context says, oh, good, you're all done. What thread called you? It says thread 1 called me. And then thread 1 jumps back in and continues running this code, so kicking off this for loop here. Now, that's not terrible, but why did we have to go back to thread 1? I mean, especially since thread 1 is our UI thread. We want to leave that free. We barely want to use that for anything except UI stuff or user interactions. And here we are, bringing it back into our view model. And in the MVVM world, like, view models don't touch the UI, so we don't need it. Plus, what happens if thread 1 is busy? Like, maybe the user's just scrolling the screen or jamming buttons, or maybe we have a game that needs to run at 60 frames a second. Well, our code is just sitting here waiting until thread 1's available to jump back in. So we could make this a little bit better, a little bit faster, by using configureawait false. So what configureawait false does so in this example, when thread 5 is done and get top story IDs is finished executing, thread 5 now with configureawait false goes to the synchronization context. Synchronization context says, great, you're done. Which thread called you? And thread 5 just goes, doesn't matter. And so the synchronization context just grabs whatever thread's available, and that thread will continue running our code. So thread 17 can jump in and kick off the rest of the method. So my rule of thumb is if I'm in the service layer of my app, or being that I do a lot of MVVM, if I'm in the view model layer of my app, anything that doesn't touch UI code, that I don't really care what thread I return to, I put configureawait false everywhere. Pretty much the only place I don't use configureawait false is if I'm in the view or I'm interacting with the UI. Now, you might be wondering, yes, that says false, so there must be a true. And if you spell it right, there we go. What does that do? Well, that's just the default. So by not putting anything, like if we didn't have this here, that's the same as configureawait true. So you'll probably never do this, but like I said, if you don't need to return back to the calling thread, configureawait false. All right, so refactor done. And we've got another one here, same story. Slap on a configureawait false, and refactor done. Cool. Making progress. All right, next up, we have a method called getStory. GetStory calls a method called getDataObject from API. So this is just hitting the Hacker News API and pulling down the story. And it looks pretty good, right? Like, we're using await, we're using async. We could probably put a configureawait false on there. I don't know if it's already there. No, it's not. But this is a cool example because if we take a look at what this method's returning, getDataObject from API is returning a task of type story model. And getStory is also returning a task of type story model. So what we can do here, we can actually get rid of this async keyword and get rid of that await keyword, and we can just return the task. Now, it feels a little weird. This is probably something that most of you haven't seen before. I don't see it a lot in code. Well, I guess, except for my code, I love this. But by just returning the task and getting rid of that await keyword, we just saved ourselves a context switch. So we didn't have to switch from thread 1 to thread 5 or thread 2 to thread 7, whatever it might be. we can just return the task and allow whichever chunk of code calls getStory to await getStory and handle that context switch for us. And by getting rid of that async keyword, well, now the compiler doesn't turn it into a iAsync state machine class anymore, and so we've saved 100 bytes in our app size, so yay. But the big benefit there is that performance impact. So we don't call the await keyword, which means we don't switch context or switch threads, and we can save that switching, and our code will run just that much faster. All right, so the next one, get top story IDs. This is the first method that runs and hits the Hacker News API and pulls down their IDs because for whatever reason, their API says you can't read a story unless you know its ID first. So great, we got to make 2 calls. This is also, get data object from API is also returning a task of type list of type string. And just like the last method, so is get top story IDs. So right, we can get rid of that and get rid of that. And this will work. It'll compile, it'll run. But this was actually a trick question because we don't want to do that here. The reason I show this is because when we return the task, that means we're not waiting for it to finish. We're literally returning right away. We're saying, oh, here's the task. It's still running in the background, but here you go. So because we return right away, that means we've exited the method, and ipso facto, we've exited the try-catch block. So if this were to throw an exception, we've already exited the method, and that exception will never be caught here. So don't do this if you're inside of a try-catch block. Make sure to use return await inside try-catch blocks. But otherwise, yeah, you can just return the task. Now, there is something cool I want to show you with this method here. Let's see, top story, what's that method called, or property called? Top story list. So let's say top story list, and let's check first to see if its count is greater than 0. And if it is, instead of going and hitting that API again, which I find super annoying, why don't we just grab the IDs we already have. Let's see, grab that ID, make sure it's a string, and that also has to be a list. Basically, why don't we just return the IDs we already have? How much of the top story is going to change in the 5 minutes that our users are using the app? Probably not that much, so let's make it a little bit more performant. But what we've just done, we've created another path in this method. So we have an async task method that the first time it runs, we're going to come down here and hit this return await get data object from API. But the second time it runs, we're going to hit this path. And we're not going to use the await keyword anywhere. We're just going to return the information we already got. And same with the third time it runs and the fourth time it runs. And so this right here is what we call the hot path in our method. So if we have the hot path in our method that does not use the await keyword, we can use this cool thing called a value task. Now, value task, this is pretty new. It's being added to .NET Standard 2.1. .NET Standard 2.1 hasn't been released yet, but value task is available in a NuGet package, and I'll share that link with you in just a bit. But what value task does is basically the same thing as a task, but it's a value type. So if you think back and remember, task is a reference type. Reference types live on the heap. Value task is a value type, and that lives in the stack. Now, if you remember all the way back to data structures classes, or if you've been studying up for an interview coming up, you'll know that it's more expensive to put something onto a heap than it is to put something onto a stack. Because when you put stuff onto a heap, it's got to be indexed. And it's indexed because, well, it's really quick to read from the heap, whereas it's a little slower to read from the stack. But in this case, we're not really using all those benefits of task all the time. So why take that performance hit 9 times out of 10 to put a task on the heap when we don't need to, and we can use value task. And so value task living in the stack, that means as soon as this method's done, it's popped up, we save a garbage allocation or a a garbage collection, and we also save that memory allocation. And so if you find that spot in your code where the hot path does not use the async keyword, does not use the await keyword, check out value task. All right, let's see, how we doing? Cool. So back up to the constructor. When this constructor loads, I call execute refresh command. That's the method that we saw earlier that will hit the APIs, it'll load all the data, and I have that here in my constructor. Maybe I shouldn't, but I want my app to load the data as soon as the app launches. I don't want to load an empty app for my user and force them to do a pull to refresh. That's silly. So I have it here in my constructor. But this is also an async task method. This method returns a task, and we're not awaiting it. And that's why we're getting that yellow squiggle right there. That's why Visual Studio is yelling at us. And so, I don't know, maybe we can do async await, and that's going to yell at us. And it should, because constructors will never be able to use async await. Constructors are just literally meant to initialize objects. They allocate some memory. Maybe they assign some variables an initial value. But they're not supposed to do anything long running. You should never have to await a new object. So that fails. Can't do that. Well, something we could do is this. And change that to refresh. So now that squiggle goes away in our constructor. And what we've just done, and I can feel the cringe going on right now, because we just made an async void method. Now, I do have a bone to pick with async void, and that is just how it's typically taught. You know, when we're first learning async and await, everybody says, if you're going to use the async keyword, always return a task. Well, now that value task is out, that's cool too. But they say never use async void. And that's not bad advice. Like, async void can be dangerous, and I'll tell you why in just a second. But the problem I have with telling developers never use async void is they never say why. So let's check out why. And I mean, spoiler alert, this is actually a valid use case for async void. We'll say it's one of the few, but it is valid because, look, we kick off this method. We cannot await it. But inside there, we are calling an async task method, and we are awaiting it. So if an exception gets thrown inside of execute refresh command, because we use that await keyword, that exception will be rethrown and surfaced back to us. But why is async void dangerous? Well, let's check this out. Let's say we did something like this. Put it in a try catch block, exception. We'll just print that to the console. And exception. So we know refresh is going to throw an exception, right? Throws it right here as soon as it's done with execute refresh command. But that exception will never be caught in this catch block. And here's why. Let's say thread 1 kicks off our constructor. Thread 1 calls refresh, so thread 1 comes into here. Thread 1 hits this await. And so now execute refresh command is running on a background thread. Let's say it's running on thread 3. And thread 1 is now coming back up here. But since we cannot await an async void, thread 1 just continues. So we'll say thread 1 continues here. And so now thread 1's down here executing some more code. Meanwhile, this refresh method is technically still running because execute refresh command, it takes a couple seconds to do stuff in the background to hit the APIs. And so when this exception triggers, we've already exited this catch block. So that's one reason why async void methods are dangerous, because you'll almost never be able to catch an exception from an async void method. Now, another reason that's dangerous is, let's say we were doing something with that top story list, right? Like maybe here we choose to new it up, story model, and I don't know, maybe we say add and we ... we do some more stuff there. So So thread 1 is now interacting with this property top story list. Meanwhile, thread 5 is running in the background doing execute refresh command, which also interacts with top story list. And so now we're going to see some really weird behavior because, which one wins? We got this race condition. So maybe thread 1 wins and we new up and we add some stuff, but then thread 5 gets there and adds some more stuff in there. Weird things are going to happen here. And it's all because of that async void. And because you cannot await an async void method. So probably the scariest thing that I've ever come across when working in some code is when there's been a public async void method that I didn't write. Like, big chunk of code, coworker in another class, or in another C# file, created the class that had a public async void method on it. Well, I mean, right here we can see it. Like, async void's right there. Got it. But let's pretend like it wasn't. And we're just using IntelliSense, right? And IntelliSense, let's see if we can zoom in on that. IntelliSense just tells us that refresh returns a void. So any C# developer worth their salt will say to themselves, and rightfully so, that, well, refresh, this method, will run to completion before it continues on and executes the rest of this code. But in reality, whoops, there we go. But in reality, it was an async void method, and now you have that method running at the same time. So that's why async void's dangerous, and why, even though this is a valid implementation and usage for async void, it's still not super recommended because, I mean, we can see it right here, but what about a couple years from now? New developers take over the same code base. They might not know that's an async void method, and they might make the same mistake that we just did right here, and now they'll be wondering why their exception's not being caught in their try-catch block. Okay, great. So what have we accomplished? Basically nothing, because we said we didn't want to do that. So back to this. Well, what can we do? Async void would be perfect if we could do that, but it feels icky, and we're setting up our coworkers for failure. So something I did, I created an extension method called safe fire and forget. So remember what I was saying earlier, why fire and forget methods are bad? Like when you say task.run, kick off some code that you're not awaiting it. Well, those are bad because you're not awaiting it. But at the same time, you might not care when that code finishes. So you might not want to say, I want to wait for this. I just want to kick it off. But I still want to follow best practices. So this safe fire and forget method, let's actually jump into that. Boop. This is an async void method. It's an extension on task. And we've got some goodies in here, like we can pass in what we want to do with configureawait, so we can still say configureawait false. And if we want to, we can also pass in an exception handler. But if we don't, that exception will just be rethrown. So that's what that means right here. So if onException remains null, that exception gets rethrown, and happy days, because that exception was exposed to us. Otherwise, in the old bad fire and forget way that we just say task.run, that exception would be swallowed forever. So I put this together so that it's blatantly obvious that you want to fire and forget this method, but you still want to do it safely. You still want to make sure that exception happens, and that you can take advantage of that in your code. Now, like I mentioned earlier, all this code's open source, so feel free to download it, copy paste it into your code. But I've also NuGetized this. So this is also available as a NuGet package if you just want to slap it into your app. That way you don't have to worry about copy and pasting code around. The NuGet package name is called Async Await Best Practices. And I'll share that link with you again in just a minute. All right, so done there. And we've got one more refactor. And let's see, refresh command. So if you've ever done anything with MVVM, you've seen commands all the time. If you haven't, don't worry about it. Maybe you'll come across them at some point. But we're getting yelled at here because command takes in an action. And what's an action return? Void. So by saying async void, well, by saying async, we've essentially just created an async void method. But again, this is another valid use case for async void. And this is totally fine. You don't have to change this at all. I mean, you get the little yellow squiggle saying that asynchronous method shouldn't return void, but you just got to go, nope, I'm smarter than that. This one's actually cool. But if you want to get rid of that yellow squiggle, I've put together another library called async command. Async command. Async command. There we go. And with this, we don't even have to say async await. We can just literally pass in that task, and async command actually takes advantage of save, fire, and forget. So if we were to jump into this code, this one's a little bit more verbose, but you can see down here, when you execute that command, it's using save, fire, and forget. But again, it's nicer because we get rid of that little squiggle, and async command also has a couple more extra properties that iCommand doesn't. So if you do want to call this command from a different class, you can actually await it, whereas normal iCommand is typically fire and forget. All right. So let's review those best practices we were just chatting about. Never use .wait, never use .result. I hate them, their code smells, get them out of your code, because we should be using the await keyword, but if in that rare point that you do have to write synchronous code, both can be replaced with getAwait or getResult. And getAwait or getResult will still lock the calling thread, but it's better because it'll throw our exception with our stack trace and our code, whereas .wait and .result both throw an aggregate exception. And yeah, that's a good point. I forgot to show off .result is also replaceable. So literally, getAwait or getResult, if your task is returning a type bool, getAwait or getResult will return that bool. If it's just returning a task, it'll just return void. So getAwait or getResult, use that to replace both .wait and .result. Don't use those. Fire and forget tasks. We'll say, be judicious how you use these. You should be awaiting every task, but if for whatever reason you don't really care when that task finishes, you want to kick it off, you want to fire and forget, but you still want to follow all those best practices and you don't want to add async void methods into your app, check out the save, fire, and forget extension method I've put together, and that's the name of the NuGet package behind me. And I've included a link to that NuGet package on the NDC Oslo async await site at the bottom. Async commands. So if you're doing commands and you want to get a little bit more flexibility around making it awaitable, having some async and await stuff, you can also check out async command, and that's also in a NuGet package I've put together called async await best practices.mvvm. Also linked below. Return await. Don't use it. If the only place in your method you're using the await keyword is in the return statement, rip it out. Get rid of await, get rid of async, and just return that task. That'll make sure we don't do an extra thread switch or context switch, and our code will run just a little bit faster. Now again, a couple caveats. If you're in a try-catch block, keep that return await in there. Otherwise, you're going to return that task right away. You're going to exit the try-catch block. Same if you're in a using block. So if you're going to dispose an object, make sure to do return await because, again, if you return the task, you'll exit right away, and then all of a sudden that object that you needed is now disposed, and you'll get weird errors like I did once upon a time. Configure await false. Use it. I use this, like I said, I use this everywhere. Every time I'm not touching code that interacts with my view, with my UI, I use configure await false. And so the rule of thumb is if you don't care what thread you return to, use configure await false. There's no reason to wait on a thread that might be busy and burning CPU cycles just sitting there waiting for your thread to come back when you can just grab a perfectly good thread, different thread from the background pool, or from the thread pool. So use configure await false whenever you don't need to return to the calling thread. And lastly, value task. This is new, this is hot off the presses. Like I mentioned, it is coming in .NET Standard 2.1. But today, it's available in this NuGet package, system.threading.task.extensions, and I've also linked that for us in the link at the bottom of the slides here. All right, so speaking of that link, if you haven't had a chance yet, make sure to take out your phones, grab a picture of this slide, bookmark it, share it with your friends, show it with your colleagues, because this is where you can find everything that we just talked about today. This is where you'll be able to find the slides. This is where you'll be able to find the source code for the Safe Fire and Forget, for iAsync command. If you want to check out that Hacker News app, if you're into Xamarin apps like I am, those are all linked there. The NuGet packages are all linked. And then if you want to continue this journey, and I highly recommend it, it's a pretty deep rabbit hole. But there's also a bunch of links that I've included there on how value task works, how async void works. And you can continue studying and reading up and going down this rabbit hole. Highly recommend it. Thank you. So it looks like we do have a couple minutes. If everybody wants to stick around, I know we have a microphone in the back, and we can shoot out some questions. I do ask, make sure we get the question into the microphone. So I saw the first hand over here. That way, anybody watching the video later, they'll be able to hear your awesome questions as well.
Hello. Thank you very much for this nice presentation. And
thank you.
My question is simple. I'm just wondering how you do unit testing of this await and async.
How you unit test async and await?
Yes.
I mean, unit tests are just C# code, so you can also use async await keywords in your unit test. That might depend on what framework you're using. I know the one I'm most familiar with is NUnit. And yeah, as of NUnit 3, you can just async await everywhere. So yeah, if you do want to await a method, you can do that. And actually, that is a cool question because I have unit tests in that library. So for all those two NuGet packages I've made, I've just got a suite full of unit tests if you want to check those out. But yeah, they're all using NUnit, and you can do async await. You can do things like checking the current thread, running something, calling configureawait false, then checking the next thread, making sure it's different, making sure it didn't go back to the calling thread. And yep, that's all available to you in unit testing.
Thank you.
Thanks, good question. Okay, great.
Hello. I was wondering if you would like to run, let's say, 2 service calls in parallel, and you use await task when all.
Yeah.
Is that a valid place to use get result, or because you after the tasks have finished, you in a way have to get the results from both of the tasks?
Right. So yeah, just to fill everybody in, what we're saying is, let's say maybe we have task 1 equals, I don't know, we'll say task.run, async await. No, let's not even go that far. Let's just say task.delay. There we go. So we got that. Call that task 2. And then what we can do is say task.whenAll. And just for anybody that hasn't seen task.whenAll before, what this does, what we've done, we're not awaiting these tasks here, but we are awaiting them in task.whenAll. So like you mentioned, if you want to kick off some things in parallel, you can start the task and then await it all together. And this will then continue when both tasks have finished. So like if this one was a little longer, maybe took longer, took twice as long, this code will continue when both have finished. So yeah, the question was, well, what if we do get a waiter,
no,
get result here?
That was actually not what I was thinking about. I was thinking about if task 1 and task 2 are returning a value of some sort, or a result, then you, after they are finished, you would like to get the results.
Oh, yes. Okay, awesome. So yeah, let's tweak this a little bit. Coding on the fly. Test.run. And we'll just say, we'll cheat a little bit here. Just, all right, so down here, we're saying, what if we say get awaiter, get result here, right?
Yeah.
Cool. So now, what's happened, right? We've kicked off these tasks. Let's pretend like they're doing something important and not just returning true right away. They're doing something important, something that's going to take a while. Await task.winAll will continue once both tasks are done. And now, task 1, we know for a fact, is completed. And so if we call getAwait or getResult, what happens? Well, if the task, we'll say tasks are kind of smart. If the task has already completed, it'll just return that Boolean value. So this will just return true right away. We won't lock up the calling thread. We won't have another thread running in the background. So this is actually okay because we're not going to break anything. That being said, just for a best practice, and I know this is going to look kind of funny, I still do this. There's, in this specific example, where we know the task is finished, there's really no benefit to call await or configure await false, because we're not going to switch threads. Like I mentioned, if the task is already completed, there's no thread switching. There's no context switching. But the reason I still await it, and throw configure await false on that if you want to, is because we might not always own this code. Maybe a junior developer comes in later and changes this around, and he's just said await task 2. Well, if we still had get awaiter, get result. If we still had get awaiter, get result here, well, now we're going to have some trouble. This is going to lock up the calling thread. So you can. In that specific example, it is safe. You're not going to get in any trouble using getAwait or getResult after a task.winAll, because you know the task is done. But I always like to think ahead, what about that future developer when they take over the code? So I will still use await, configure await false, even though it technically doesn't do anything at this moment in time. Does that make sense?
Yeah.
Awesome.
Is there any
Great
difference between using task1 getAwait or getResult versus task1.result after the task1L has finished?
Yeah, let's put that up there. So, yeah, like what's the difference? Whoop. Do that versus get a waiter. It's a little bit more verbose, but that's okay. So yeah, now the question is like, well, what about .result versus getAwait or getResult? So these, again, will just both do the same thing. Like even, let's throw all 3 examples up here at the same time, because they all will be doing the same thing. Actually, we'll throw in a 4th one, because we can say configure await false. So because task 1 completed here, if task 1 had thrown an exception, that exception would have been thrown right here. So we never would have even got to this point. And so we know the result's there waiting for us because that exception would have killed our code right here. So yeah, .result, .getAwait or getResult, await, and await, configure await false, these are all doing the same thing. But like I said earlier, this one's my favorite. Just for that dev a couple years later, so they don't all of a sudden break the app. Great question, though. Thank you.
Thank you.
Sounds good, yeah. Got a little bit more time. Looks like about 5 more minutes. Oh. We'll queue you up next. Hi.
I'm wondering, when you're writing web apps with ASP.NET, do you always want to configure await false then?
Oh, yeah. So do you always want to configure await false even in, say, a web app?
Or do you have to do it in all your awaits in a web app to be compliant with your suggestion, because you're never touching any UI? And
Right, like what if you're never touching a UI? This is an interesting question. So technically, there's certain apps that don't have that UI thread, and those apps actually won't have a synchronization context. So if you remember, the whole point of the synchronization context is to remember who called what thread so that we can go back to it, and that's all literally because of UI stuff. So I know, let's see, like .NET Core doesn't have a synchronization context. So in that case, if you call configureawait false in an app that doesn't have a synchronization context, it'll just do the same thing as if you had not called configureawait false, because there's literally nothing there orchestrating the threads. So yeah, great point. Thanks for bringing that up. Yeah, if we had another question here in the middle, and oh, so yeah, my best advice, since we can't cover everything. Oh, cool, we got another one over here. Oh, I'm sorry. Just real quick. Yeah, the best advice I can give for that question is just throw that into Google. Whatever you're working on, like say like Entity Framework, does it have a synchronization context? And if it doesn't, then configureawait false will do the same thing as configureawait true, or never using it at all. Thanks for bringing that up.
If you have multiple calls, so one function calling another one, and that you await in every call, do you configure await for the first call or all the inside calls?
Great question. Configure await all the way down. I wish .NET was smarter. Let's see, what's a good example? Let's put this back to, So let's pretend this code was still like this, right? This command kicks off. All it's doing is awaiting this method. .NET isn't smart enough to know that this is the last line in a method and to not switch back to the calling thread when it's done. So I know it looks weird, but if we were going to do something like that, we'd still want to use configureawait false even here. So even if it's the last method, the last line of the method, .NET still is going to bring you back to the calling thread if we do not use configureawait false. So yeah, all the way down. Unless you need to return to the calling thread, of course.
Yeah, so when you start going down this rabbit hole with Async, you sooner or later get to a blog article by Stephen Cleary, I think his name was, where he says there is no thread. So you don't necessarily get a new thread from the thread pool if you do an await. Is that true or not?
Oh man. So this is what I meant by the rabbit hole goes deep. All right. So first thing, if you've never heard of Stephen Cleary, it's spelled Stephen Cleary. Check him out. He's the de facto expert on async and await, and he's probably the only person in the world I would trust, not even myself, talking about async and await. Like, I think I know my stuff, and then I read an article from Stephen Cleary, and it's like, oh, guess I didn't know anything. So yeah, that article is called "There Is No Thread," and there's a couple things going on in there. I think probably the most relevant one, because he does get into like some nitty-gritty technicalities on how disk I/O works, and to be honest, I just don't remember everything he said. It's a great article, do check it out. But things like this right here. So we said task.run, but we never used the await keyword in here. .NET's not going to put that onto a different thread. Like if you think back to, remember move next, that giant switch statement? Well, there's only going to be one case. And so if thread 1 calls this, thread 1's just going to fall right through, get to the result, and return it. And we'll return the result. Because we never use the await keyword. So yeah, there's kind of two parts to that blog. And like I said, like one is like the deep stuff on like how disk I/O works and why technically with C code, like that's still beyond my capabilities. But yeah, the other big point there is if you don't use the await keyword inside of a task, .NET's not going to put that task onto a different thread. So that's a good point to make. And because of that, not every task is a thread. Did I just confuse everybody? Awesome question, though. Anybody else? All right, thanks so much for coming, everybody.